shape of an inverted cone, just for you guys, because I knew you loved it yesterday. I predicted you would love it so much that I already had one ready to go in the note sheet. Okay, is 30 centimeters deep and the diameter across the top is 20 centimeters. Then we have, this one's tricky. We have two things going on. We have liquid being poured in at some constant rate, and it's coming out the bottom at the same time. Okay, so we don't know how fast it's coming in, but it's coming out at a rate of 12 cubic centimeters per second. What would that be? 12 cubic centimeters per second. What is that talking about? That's volume. And it's per second means it's how it's changing. So we're looking at dV dt. Now, we have to put a little extra thought into the volume this time because there's multiple things going on. We have water coming in and coming out. If I said it was going in at a rate of 20 and coming out at a rate of 12, what would the change in my volume be? 20 minus 12. So we need to know however fast it's coming in minus 12. Now, I didn't tell you how fast it was coming in. All I told you was that is a constant rate. So I'm just going to call that C for a constant. However fast it's coming in minus 12. The height is rising at a rate of 0.25 centimeters per second. What is that? dH dt is 0.25. At the instant when the liquid in the funnel is 20 centimeters deep, what's that? H. At what rate is water being poured in the funnel? So we are trying to find C on this problem. Okay, so we had one yesterday, and what was the formula I gave you for volume of a cone?
Yeah, it's just definitely square. Just
Okay.
roll it away.
It's like, oh, did I tell you the wrong thing yesterday?
No, just
Okay. Do we want to jump in with the derivative on this? Why not? Yeah, we don't have any information about the R here. So, what did we do yesterday? We set up a ratio to find R, didn't we? So we could say 30 over, is 20 my radius? No, what would the radius be? Yeah, the 20 is my diameter, so the radius would be half that, which is 10. So 30 over 10 would equal H over R. So 30R equals 10H. Divide by 30, so R is H over 3. So I'm going to plug that in before I do the derivative. 1/3 times pi, I'm going to write that as pi over 3. R, so H over 3 squared times H. Pi over 3 times H squared over 9 times H. I'm going to write that as pi over 27, H to the 3rd. Is everybody following my math there? And again, the whole reason I did that is because in my information, I don't have anything about R or dr dt, so I want to get rid of that before I do my derivative. Now we can do the derivative. So derivative of v would be here, I bring down my 3, so pi over 27 times 3. Pi over 9. H squared, and then it needs dH dt. So plug in what we know. dV dt was c minus 12. Was pi over 9. H was what? 20. And dH dt? So 20 squared is 400 times 0.25 is 100. I get 100 pi over 9. Add over my 12. So the rate is 100 pi over 9 plus 12. You could certainly give me a decimal if you wanted. Now on a test, we know we don't have a calculator, so we can force leave it like this. But we could plug it in if we wanted. What would my units be? Cubic centimeters per second, because this is how the volume is changing. It's how fast you are pouring water into that gun. See, look how fast we flew through that. It just gets easier and easier. That one over here is so then I want to look at this next example. This one is like the problem 13 that I kind of helped you guys start yesterday, but I didn't actually finish with you. And I kind of figured we might have some problems with that, so I wanted to do one like it together, and then maybe you can go back if you didn't get that one finished yesterday and make sure you got it correct, okay? So we have a man 6 feet tall, walks with a speed of 8 feet per second away from a street light that is atop an 18-foot pole. How fast is the tip of his shadow moving along the ground when he is 100 feet from the light pole? So very similar to yesterday, just different numbers. What do we need to do? Draw a picture. We know that we have this light pole, and it is 18 feet tall. And we have this man that is walking away from the pole. This man is how tall? 6 feet tall. Okay, the 8 feet per second, that's the speed he's walking. So if I'm going to talk about his speed, I need a variable for his distance. So what do we want to call that? X. So then dx dt, the speed, is 8. Where is his shadow going to be? Out in front of him. Your light's behind you, your shadow is out in front. Okay, so his shadow is here. We want to know how fast that is moving. So since I need the speed of his shadow, we need a variable to represent the whole shadow. Okay, so that would be our y. We are looking for dy dt. When he is 100 feet from the light pole, so what is that? No, it's not. It would be x, wouldn't it? Y is how far his shadow is. He is 100 feet, so that's x. Okay. What do we want to do? height of 18, and this length is y. Then we have that small triangle. It has a height of 6. What would this length be?
Y minus x.
Y minus. Okay, if we have similar triangles, what can we do? How do we set up a problem involving similar triangles? Oh, come on. This is algebra 1.
I don't remember this.
I don't wanna get
I don't
confused.
remember that. That's
That
too
was
long.
way
Oh, we've done it and we did it all the time in trig too. Set up a proportion. So we could say like 18 over y equals what?
6 over y minus x.
Thank you. You've redeemed yourself. Okay, so then what do we do? Cross
Yeah.
multiply. So we get 6y equals 18 times the y minus x. Alright, I'm still just trying to set up my equation. We could certainly do the derivative at this point. You might want to go ahead and combine some like terms and things first and get your equation reduced a bit. What would you do if you wanted to do that? Alright, subtract over 18y. Again, you could go from here and do your derivative. You might also just divide each side by -6 to get it in lowest terms. So we get 2y equals 3x. So now I'm going to do my derivative of that. So what would be the derivative of 2y? dy dt. And what's the derivative of 3x? So then we plug in what we know. Dx dt was 8. So dy dt is 12. Y was measured in feet. T was measured in seconds. So the shadow is moving 12 feet per second. Are there any questions on this one? So this should give you what you need to go back and finish problem 13 if you didn't get that one done. I would like for you guys to see how far you can get on this one. What can we do so far? Draw a picture. We have a right triangle. The height is 1/3 the length of its base. So what do I do with that?
I just did like x as the base and did 1/3 x.
Yep. Perfect. How fast is the area changing? So what am I looking for?
dA dt.
When the height is 5 centimeters and increasing 2 centimeters per second. Okay, so here's an issue. I am telling you how the height is changing, right? So I'm saying your height is 5 and the dh dt is 2. But what we have set up in our picture, we used the base. for the variable, not the height. So we have to switch our variables to match the rate that's given. So while x and 1/3 x were a great start, that doesn't really match the rate I'm given. So I need this to be my h. Now if that is 1/3 the length of the base, what would our base be?
3H.
3h. Had I given you how the base was changing, we would have stuck with the 1/3 x and the x. But because the rate I gave you was for the height, I want my height to be my plane variable. And so I had to change my base to be 3 times that. Does that make sense to everyone? Okay. So it's all about what information is given to us. We have a triangle. How do we find area of a triangle? Yep. Okay, but again, I don't have any information about the base. So before I do the derivative, I need to get rid of that b. So what did we say the base was equal to? 3h. So my area is 3/2 h squared. So now we can do the derivative. So dA dt. 2 comes down, so 3/2 times 2 is 3. H, subtract 1 from the power, times derivative of h would be dH dt. So we get 3 times 5 times 2. So dA dt is 30. Units, area is square units. We were in centimeters, I think. Yeah, square centimeters per second. All right. Questions? So, that is our stopping point. You have the rest of the class period to work. I am adding more problems today than I have been. So there are 6 total problems I'm adding today. Tomorrow will also just be a work day for these problems. So we have the rest of class today, class tomorrow, and then they'll all be due on